Hello guys, just thought I should give you a bonus tutorial on autotransformers, since you're going to write a quiz tomorrow and we had not yet made plans on how to assist each other. But I'm just going to try and explain it in brief, and then I do maybe 2 or 3, okay, 1 or 2 questions, and then maybe they will assist you in understanding what autotransformers really are. So this is just to assist you, maybe to help you understand it better. So autotransformers. Transformers. So I'll go straight into the explanation. Autotransformers, you know, a recap on the 2-winding transformers that we've studied so far. If we take a look at an ideal transformer, you will see that it had 2 windings. Windings on the primary side and the windings on the secondary side. Okay, so this was NP, this is NS, and then right here we have VP, and right here we have VS, then here we have IP, and then here we have IS. So this was the conventional 2-winding transformer that we understood before when we were doing this. Now, if you look at this, you realize that there is no electrical connectivity between the primary side of the transformer to the secondary side. So that means the transmission of energy from the primary side to the secondary side is all due to what? Induction between these 2 coils. So we can say that the transference of energy from this side to side is solely due to induction. There is nothing else that transfers energy from the primary side to the secondary side. Now, with an autotransform, the difference is that we will now have 2 ways in which energy is being transferred. So let me do this. Normally, we would draw, if we were drawing this physically, the physical drawing of the transformer, we would have such a thing. We would have coils here on the primary side and coils on the secondary side, and they are not electrically connected. Okay, but now with an autotransformer, what happens is that we will have some sort of connection between electrical connectivity between this primary side of the transformer to this secondary side of the transformer. So that means we have some sort of connection between these 2. Okay, that means that we now have 2 ways in which energy is being transferred. So we have energy being transferred in form of what? Electrical connectivity. And then we have energy that is being transferred in the form of induction, by induction. So now we have 2 ways in which energy is being transformed on an autotransformer: electrical and induction, by induction. But how do we draw it now when we are solving our questions? We don't really have to draw the physical appearance of the transformer. So what we do, draw it this way. So we have something like that. So now it depends with whether your transformer is going to be step down or step up. So let me just do this. I'll draw this down and then I'll explain. Okay. This is the way in which it is drawn. So this is one form. So there are 4 different forms, or 4 different ways in which an autotransformer can be connected. Now, what you must remember is that an autotransformer is made from the general two-winding transformer that you understand. So this is one way in which an autotransformer is connected. But now let me help you probably understand this better. So let's say we said this one is an ideal transformer. So therefore here we have EP and here we have ES. And since it's ideal, and since ideal, that means that from here we can see that VP is equal to EP. And VS is also equal to ES. Okay, since it's an ideal transformer. Let's not talk about the number of turns here. And we have NP here, and we have NS there. Okay, so now, if we are going to take the rating of this two-winding transformer, it will probably be given as maybe S. So this, I'm taking this as the rating of a two-winding transformer. What can I do? Let me just say TW. So TW represents the apparent power of a two-winding transformer. And then, so that is the rating, sorry. And then we have VP stroke VS. Or sometimes you can say, just say EP stroke ES. So this is the rating. Let me clarify that for some people. So if we are having values, then it will be maybe, let's say it's 24 kiloVAR. And then here they will tell us maybe 100 volts. And here maybe we have 60 volts. So this is the rating of a two-winding transformer. Now, when we are given this two-winding transformer, what we'd want to do is we want to connect it as an autotransformer. So there are 4 ways in which we can connect it as an autotransformer. Okay, so number 1, the first way in which we can connect this as an autotransformer is the way we've connected it here. But this shows that we are going to have a step-down transformer. Why? As you can see on this side, we're going to have a bigger voltage than the one that is going to be on this side. So we're going to have a step-down transformer. So if I say this is a winding that was on the primary side of the two-winding transformer, then this becomes EP. And if I say that this is a winding that was on the secondary side of the two-winding transformer, this becomes ES. Okay. So now, if I want to find the EMF on the primary side of the autotransformer, let me call that EPA, because now this is an autotransformer. This is a two-winding transformer. And then if I want to find the EMF on the secondary side of the autotransformer, this will be ESA. Now on here we have ISA. Here we have IPA. Okay, and then these will meet somewhere here. Okay, now if you read, when you're doing your studies, you realize that there are certain names that they're being given to these terms. Now here, this EP is represented as the series EMF. It's the series EMF. Okay, and then this one is represented as the common EMF. Okay, now here we have a current that will be flowing. This is the positive side, that is the positive side of this one. So now, normally people find it difficult to know the directions of the currents now. Okay, now let me help you here. I'll help you in this way. When we are stepping up, when it's a step up in a transformer, if it's a step up, then you will see that we have a lower voltage. We have a lower voltage here, and then here on this other side, when you step up, we have a high voltage on this side. But if it's a step down, you will see that we have a higher voltage here, and then on this side we have a lower voltage. But now what happens is that if you check the values of the currents, you will see that on a step-up transformer, the currents here, we have a low current here, where we have step-up, and then here we have a higher current. Then if it was a step down, is a step down. If it was a step down, you will see that here we have a lower current on the high voltage side and a higher current on the low voltage side. So that is all you need to remember. So now if you want to know in which direction the current is going to flow in this common winding, you will say this, on this side we have a higher voltage. That means we should have a lower current here. Okay? Is it? We should have a lower current there. Then that means when we step it down, we should have a higher current there. Now for us to have a higher current, that means the current that is coming on this side, it must somehow add to the current that is coming on this side. Then they become a bigger current. Because if we connect this one and we say that the current is going in this direction, you will see that when it comes here, it will be separated. That means this one will be smaller than the one that is coming here. That's why, that's all you need to remember. So on this side, the current is always going to, the currents are going to add up. The common current and the series current will add up to give us the what? The secondary current in an auto transformer. So this current on this side is called IC. Okay, and it's pretty easy to calculate. I'll explain that just now. And the current that is coming on this IPA, you can also call it ISE. Okay, good. Now let's go to this. You should understand this one. So remember, all these things are coming from the secondary winding. So from the secondary winding, we see that we have EP, and that EP on the auto transformer is now called ESE. And then from the two winding transformer, we have ES, and that ES on the auto transformer is known as EC, which is pretty simple. So let's do this. So what is the EMF on the primary side of the auto transformer? Now that one can easily be seen. The EMF on the primary side of the auto transformer is given by the sum of these two. If you look at this, they are going to add each other. Or even if you take what is that, KVL around this loop, KVL around this loop, you will see that we have EPA is equal to, this one becomes, sorry, KVL there. So if we take it out, it's going to be EPA gonna be EPA. Then here, remember this is positive. This is positive. That's why I have those dots. So that means this is a negative, and that this side is a negative. So I'm going to have EPA, and then here I have minus EP, and here I also have minus ES. And if I go to 0, then if you rewrite that now, you are going to see that your primary current in the auto transformer is EPA plus ES. So it's simple. You're just adding the two from the two winding, and this is also equal to VP plus VS. Also very simple. Eh? Okay. Now, what is the EMF on the secondary side of the auto transformer? The EMF here is the same as this EMF. You can see that if you put an ohmmeter on, what is that? A voltmeter here, you just record the EMF that is on this side. So secondary side of the auto transformer is equal to ES from the two winding transformer. Okay. So whenever you don't see an A, this is the terminology I'm using, and I think that's what Guru uses. Okay, so whenever you see that there's no A, that means that quantity you have there is from the two winding transformer that you already know. Okay, so these values are from the two winding transformer. Okay, are we together? Here also, all right, let me explain this one here. Now let's look at the currents. If you want to find the current that is flowing in the primary side of this transformer that I drew here. Now, on the primary side, I have IPA, this one. Now you ask yourself, in which winding is that primary side current flowing? Now, if I look here, I see that it's flowing in the winding EP. Now, EP, this winding here, let me put the winding terms also so that I don't mix things. So here we also have NS, which can also be called NC common. And here we have NP, which can also be called NSE symbol. All right. So the winding that we have here is the primary winding. Okay. Now what you ask yourself is, so I'll go back to the two winding transformer and ask myself, what is the current flowing in the primary winding? That current is called IP. So this current should also be the same current flowing in the same winding. So that means that in this winding here, IPA, where we said also we are having ISE flowing, that means that it is also equal to IP from the two winding transformer. That is also equal to IP from the two winding transformer. If you didn't really understand this, you can just, rewind and then you understand as I'm explaining again. So you ask yourself, in which winding is that current flowing? So it's flowing in the primary winding. That means in the two winding transformer, the primary winding current is IP. That's the one that is flowing there. Now I'll go to this one. Here I have the secondary winding. That means IC here can also be written as I secondary, which can also be written as what? In this case, so it's fine like that. I secondary, okay? So this current here, because we have the secondary it's flowing in the secondary winding, it must be the current that is flowing in the secondary winding of this two winding transformer. Okay, so that means IP A is actually equal to IP in this case, and that means that IC is actually equal to I S. Remember, whenever you don't have an A, that means this is coming from the two winding transformer. Okay, so this arrangement now, the way they write it now is that, now what I will do is they write it in form of a transformation ratio, in the form of a transformation ratio. Let me do this. Normally when you write the ratings, we write S, and then we put the primary voltage here, VP, and then we put the secondary voltage. Okay, so I want this the way they name it. So that means on this transformer, what I want is VPA over VSA. Okay, now if I look at that, now I'll see that what is my VP? My VPA is the same as EPA, because right now I'm still dealing with the ideal. It's the same as EPA. My VPA is the same as EPA. So my VPA, if I check here, I'll see that I have VPA is equal to EPA, which is equal to EP plus ES, which is equal to VP plus VS. So this one I'll write it as VP plus VS over VSA. If I check VSA, VSA is equal to VS here. So this will be over VS. So that's how they name these things. If you check in your book, so you have VP plus VS over VS. So that means they took the primary winding, then they connected to the secondary winding, then it became our primary of the autotransform. But then the secondary winding of the two winding transform became the secondary of the autotransform. Let me say it again. The primary winding plus the secondary winding of the two winding transform, it became the primary winding of the autotransform. because it's up there. It's a primary winding of the autotransformer. Okay. So I'm going to go straight into the other ways in which these transformers are arranged. I thought this video was going to be quick, but I see that we still have to talk about a lot of things. Okay, then the other way in which it can be arranged, I'm going to use this notation here. So the other way is I can choose to say I want my primary winding of the two winding transformer to become the secondary winding of the autotransformer. Okay, so let me do this so that you see it nicely. I have two winding transformer on this side and I have an autotransformer on this side. So I have the primary winding here and I have the secondary winding. So on the autotransformer, I need to put two things. Connect two windings together. Okay, so the first one we just did now, this one, is we chose to say VP, we chose to add the two, right? And then we connected VS on the secondary side of the autotransformer. Okay, now the second arrangement, I can choose to say on the autotransformer, I still have VP. I still connect because this is still what? A step down transformer. I still connect VP plus VS. But then on the secondary side of the autotransformer, I don't choose to put VS, I choose to put VP. That means I choose the primary winding of the two winding autotransformer. So of the two winding transformer, the primary winding of the two winding transformer, I choose to make it the secondary to the autotransformer. These terms are too much, né? All right. Okay. So this is when you are doing what? When we are stepping down. So let me draw this direction, this one here. So that means when you're stepping down, the diagram is going to be the same as this one. So it's going to be like that. Okay, it's the diagram for a step down. It will always be like this. We have two windings on the primary side and then one winding on the secondary side. The only difference is, what is this winding? So you can see that in the first diagram, we chose the secondary winding to become also our secondary winding on the autotransformer. Now, I'm saying now in this case, I'm going to do the opposite. I'm going to say this becomes my primary winding. So the primary winding has now been connected to the secondary winding of the autotransformer. Okay? Now that means this one is the secondary winding of the two winding transformer. Okay. So that means here we have VS here and we have VP here. So if you're going to write this one, they know it as VS plus VP over VP. This is the same, it can be interchanged. That's why you see I start with VP and VS. So this is a step, see it's a step down, just that now it's the primary side that is now on the primary side of the two winding transformer that is now connected on the secondary side of the autotransformer. Let's look at the other way in which these are connected. Now we are going to look at what step ups. So if it's a step up, it means we have a lower voltage at the beginning on the primary side. Then on the secondary side, we have a higher voltage. So what we have here is a step up. And again, the diagram is the same. Step up diagram is always going to be the same. Yeah, I drew this. It's fine. It's fine. Always going to be the same. The only difference is you choose where do you put VP from the two winding transformer, where do you put VS on the two winding transformer. So on this one, I want to choose to put VP here and then VS here. And this one I want to choose to put VS here and VP here. You understand the difference? Now that means on this one, my VSA is going to be equal to the sum of these two, VS plus VP. And then my VPA is just going to be equal to VP. So when they write it, when they give the name to this one, it's known as a VP over VP plus VS. Okay. And when you check this one, if you look at this one, this is VPA, and this one is VSA, and that one is simply VS plus VP, and this one is equal to VS. So when they write it, the name this given to this arrangement is VS over VS plus VP. That's simple. And now if I give the other ways that these things are labeled in green, this one is known as ES, and it's also known as blue. This is blue. Yes. ESE. It's the series one, eh? And the current that is flowing there is ISE, which is series current, which is also equal to, it's also going to be the current that will flow in the secondary of the autotransformer, ISA of the autotransformer, which is also equal to, remember this is the primary one, this was the primary winding to the two-winding transformer. So that means it's also equal to IS from the two-winding transformer. Okay? And then here, remember we can write this one as E common. Okay? You can write this one as E common, which is also, can also be written as EP. This is the primary. And the current. Now I also need to calculate to explain where the current goes here. Okay? The direction. Now here, the current actually goes in this direction. Here, the current is going in that direction. Here, it's entering. I'll explain again in the terms of the step up and step down. Remember, when we are stepping up, step up transform, low voltage, high voltage. Okay? When you step up, we are coming from low voltage to high voltage. That means here we have high current. Here we have low current. Okay. So now let's use this. So if we are stepping up, remember we are stepping up here. Let's use this to know where is the direction of this current. Okay. So this is the low voltage side. Therefore, we must have a high current. This one people won't see. That color you won't see. Let me put red. We have a high current here. That means PA must be high. But then, if on the secondary side we are supposed to have a low current, that means some of this current is gone this direction. That's the way you know the direction. Okay? So that means in this direction we are going to have I common, which is also equal to I P from the two-winding transformer. Remember, whenever you don't see an A here, that means it's a two-winding value, calculated from the two-winding terms. So I would want you to do this on your own, the same notation and arrangement. I think this will help you, understand how you can do the calculations in autotransformers. Now, this is just ideal transformers. And now I see that the video is going to be a bit longer than I expected. I thought I was just going to go in a fast way, but then unfortunately the information is a lot. But let me just give one example, at least one example, then probably that one will assist you in these solutions. Just one example. All right. Let's do an example. So the example we have is we are given a example. We have, let me type this one. We have a 24 kilo var 2400 stroke 240 volts transformer, two winding transformer, transformer is to be connected as an auto transformer. For each possible combination, determine A, V, the secondary winding voltage. Sorry, that's the primary. And yes, the primary winding voltage, it's fine. Whatever. C, the transformation ratio. I didn't explain about the transformation ratios. Ratio of the auto transformer. The auto transformer and the nominal rating. The nominal rating of the auto transformer, the ATX. So that is the question. So that is the question. Okay. All right. So that's what we have. We have so in this question, we are given a two-winding transformer and it's rated. It is okay. Sorry. It is that is the apparent power. That's VP. That's the primary side. And this one is VS. And this one is S. Okay. So that is a two-winding transformer. Now we want to connect it as an auto transformer. And we said there are four ways in which it can be connected. So they are saying for each of those combinations, you need to calculate the secondary winding, the primary winding, the transformation ratio. There's a transformation ratio of the auto transformer in the nominal rating. So I would do two. I would do one for step up and one for step down. Then you do the rest. Step up. So the arrangements now. So a step up, we said the arrangement is the same. So we know that we're going to have one here, and then here we're going to have another winding there. So this is the arrangement of the step up auto transform. Okay. So now, since I said I'm going to do one, I'll choose this one to be the primary. So if I say this, I'm going to have VP. This is going to be the primary tens. This is going to be the secondary tens. Then here I'm going to get this one you can call it EP also. So you can call it ES also, right? I'm going to have here I'm going to have VSA secondary on the auto transformer, VPA primary on the auto transformer, IPA primary on the auto transformer current, and ISA. All right. Now, the directions of the currents, we already know. I already said here, should be high, so it's in that direction, that is that direction, so this one must be in this direction. So I have IC there. Okay, so let's answer the question to this one. So that means here, on NP here we have EP. Here we have ES or ESE. So what is the secondary voltage winding? That is this one. Secondary winding voltage, that VSA, is going to be equal to the sum of these two. It's going to be VP plus VS. Remember, here we have EP, we can call it V. This I do, that's why I'm saying EP is the same as VP. If you don't understand this, you have to go back to your understanding go back to your transformers. Yes, and then here this can be called VP. Sorry, what am I doing here? This is VS. Yeah, VS. Okay, so our VSA is the same as VP plus VS. So that is simple. What is our VP? We go to this one, VP. We see that the VP is actually equal to 2400 plus, and the VS is 240. Now, if you add those, you get 2640 volts. So this is the primary voltage of, the secondary voltage of the autotransformer. Now, the primary voltage of the autotransformer. Now here you can see that the primary voltage is the same as the primary voltage on the two-winding transformer. This voltage here is the same as the one that is here. So that is equal to 2400 volts. So we have already answered this one and that one. The transformation ratio, simple. Transformation ratio is just equal to the primary voltage over secondary voltage. Primary voltage is 2640, secondary voltage is 2400. And if you simplify that, what do you get there? Just 240 and 00, 800. So you get a 1.1. That is our transformation ratio for the autotransformer. That's C. So this was A, this was B, this one is C. And D, the nominal rating of the autotransformer. The rating, we are talking about the apparent power. Okay, it's something that is amazing with autotransformers. You should know, especially when you're talking about these transformation ratio. For autotransformers, we don't have the same transformation ratios for all the combinations. Each combination is a different transformation ratio. Okay, so this one is its own transformation ratio. It's different from the other arrangements. Okay, you should also look into that one. If I want to see this one, okay, I'll do that later. Or you ask me, or you can just check in your book anyway, because I see that there are a lot of things to do here. Okay, so S. So the nominal rating, we're talking about the apparent power. So S, if I say S is gonna be equal to S of the autotransformer. Let me say it's the input. S in of the autotransformer. It should be equal to VPA times the current IPA. Simple, eh? So what is my VPA? I already know that my VPA is equal to 2400, but what is my IPA is the question. Okay, so that's why you need to be careful. So my IPA, I come here now. What can I calculate here? I can see that from the diagram, IPA using Newton, what is that? Kirchhoff's laws, current law. I can see that IPA is equal to the sum. Is it the sum? Yes, it's the sum of ISA plus I common. Check here. Because this current here is going that direction, this one is going in this direction. So this one is the sum of these two. But what is this current here? Remember we said we check in the two winding transformer, what is that current? It's S. So that current is equal to IS. What is this current here? In the primary winding. So it's actually IP. But where do we get IP and IS? Simple. So I've seen here that ISA is actually equal to IS and IC is actually equal to IP for this arrangement. But what is IS? IS, I go to this one. IS is equal to the apparent power divided by the secondary winding voltage. So it's actually equal to S of the two winding transformer divided by the VS plus here S of the two winding transformer divided by VP. So you'll see that you have 24 kilovar. So divided by the two windings 240 plus 2400 divided by 2400. So if you divide these, I'm sure you're going to get 100 here plus a 10 there. And your answer is 110 amps. You can do it the way you want. Some people would calculate IS on the side, just this IS on the side, which is simple. They'll just calculate IS on the side, which will give them the normal way we calculate IS in the two winding transformers, which will give you 100 amps. And then they would calculate IP, which will give you 240000 divided by 2400. Then that gives you 10 amps. Okay. Now, then they will add the two, then it will still give you 110 amps. Okay. So that means now we have our values. We have IPA, which is IPA in the primary side. IPA is actually 2640. No, that's not the primary one. IPA is right here, which is 2400 times IPA, which is 110. So VPA is 2400. I was saying IPA. VPA 2400 times this one. Then we get, if you multiply that one, you get your value. Which is the value? 2400 times 110. It gives us a 264 kilovar. So how do you write the rating? Then the rating is going to be this is an autotransformer of a 264 kilovar autotransformer. Remember, rating is just supposed to be like this one here. And then on the primary side of that transformer, we have a 2400 volts. On the secondary side, we have a 2640 volts. So that is how we now, this is the rating, the nominal rating. So it's a step what? It's a step what? Okay, so that's how you do this one. So you just need to be careful on the calculation of the current. Okay, that's where you need to be careful on the calculation of the current. Oh, I was thinking I was going to do all the things, but let me just do the last one. Let me just try to do the last one. So we know the values that we have here. The last one we're going to draw. I said now this one is going to be a step down. So we have a step down. So we're going to start like that, like that. Okay. Now right there, this one is a step down. Okay, so if it's a step down, then here we have VPA, here we have VSA, right? And then this one. Now let me choose to change things a bit. So remember, you choose which one do you want to connect here. So if I connect here, if I connect the secondary, then here I'm going to connect the primary. So that means here I have E, P. I also have P there. Here I have ES. I also have IS there flowing here. And I already gave you the directions of this current. So here the current is going like that. So that's IS. Now you see that there are many ways of noting down these currents, but all it takes is, do you understand? Here that current is known as IPA, and why it's here it's known as IC. It's the same current, but just given different names. Here it's ISA. Simple. So what is the A? We say the secondary voltage. Secondary voltage is just going to be equal to VS. Just look here, we have ES, that's why we have VS also. Ne? So VS is also there. So ES, this voltage is the same as the voltage here. So this one is just ES. This also equal to VS, okay? So that voltage is basically, what is that in the secondary one? The secondary side of our transformer is 240 volts, okay? Then VPA, what is the primary one? Is the sum EP plus ES, which is VP plus VS, which is just the same as 2 plus 240. This gives us 2640 volts. Okay. The transformation ratio is just VPA over VSA. Simple. 240 divided by 2640. If you calculate this one, you get I think you get a fraction. Value is about 0.0909. Transformation ratio. Then D, we want to calculate the rating, and remember the rating is we need to calculate the current first. So again, choose to calculate the current. How do I calculate the current? PI in of the auto transformer is equal to VPA times times IPA. So what is VPA? We already have VPA, which is what? 2640 volts multiplied by, what is the IPA? IPA is right here, and you can see that this is the same as what? IP. So IPA is actually equal to IP. So it's actually equal to 2640 times IP. IP from the two-winding transformer is equal to 24. This is the rating, the apparent power, divided by IP, which is 224,000. This one cancels that one, that one, that one. This one is 1, so that is 10. So if you multiply that one, we're going to get 26400 kVA. Sorry, not just VA. And this will give us a 26.4 kVA. So it's 26.4 kVA. So the rating is going to be written as 26.4 kVA. And then the primary voltage is 264. This is primary of the auto transformer, volts stroke 240 volts. So that's how you do this. I just did the ideal transformers. Unfortunately, I'm now tired. Okay, so at least this is a bonus video anyway. So just probably to help you understand